We're asked to solve the equation tangent x equals 1 for all solutions, give degree answers, use k to represent any integer. We will solve this equation first using reference triangles, then verify the solution using the unit circle, as well as graphically. The first thing to notice here is the tangent function value is positive, and since tangent theta is equal to y divided by x on the coordinate plane, y divided by x is positive when both x and y are positive, or when both x and y are negative, which means the solutions will be in the first quadrant or the third quadrant. The next step is to find the reference angle that gives a tangent function value of positive 1. Having a tangent function value of positive 1 should remind us of a 45, 45, 90 reference triangle shown here below, where tangent theta is equal to the ratio of the opposite side to the adjacent side. Notice tangent 45 degrees is equal to 1 divided by 1, which is 1. So now we sketch a 45-degree reference angle in the first quadrant and the third quadrant. Let's also sketch the reference triangles. In the first quadrant, both legs are 1. The hypotenuse is square root 2. In the third quadrant, both legs are negative 1. The hypotenuse is square root 2. Notice for both reference triangles, the ratio of the opposite side to the adjacent side is equal to positive 1. And now let's work on determining all of the solutions. Let's first focus on the least positive angle in the first quadrant, which we can see is 45 degrees. So we have x equals 45, but we want all the solutions, and therefore we need an expression for all the angles that are coterminal to 45 degrees. To find coterminal angles, we add or subtract multiples of 360 degrees, and therefore we have x equals 45 plus 360k, where k represents any integer, and the units on this expression would be degrees. And now let's focus on the least positive angle in the third quadrant, which should be this angle here. Notice this angle will be 45 degrees plus 180 degrees, which is 225 degrees, which gives us x equals 225. And then for all the coterminal angles, again, we add 360k. So while these two expressions do give all the solutions, there's a simpler way to express these solutions since the period of the tangent function is 180 degrees. Notice how the terminal sides of these angles point in the opposite direction. So if we started with 45 degrees and then added 180 degrees, we would get the angle 225 degrees. If we added 180 degrees again, we would get another angle that's coterminal to 45 degrees. So a simpler way to express all solutions for the equation tangent x equals 1 is x equals 45 plus 180k degrees. So let's go ahead and give the final solution in this form. Now let's go to the unit circle and verify the solution. Since tangent theta is equal to y divided by x, and we want y divided by x to be equal to 1, we're looking for points on the unit circle where x and y are equal, which we can see occur at 45 degrees, where both x and y are square root 2 divided by 2, as well as 225 degrees, where both x and y are negative square root 2 divided by 2. So the two angles we found using the reference triangles are correct, but again, because the period of the tangent function is 180 degrees, we can write all solutions in the simplified expression as 45 plus 180k degrees. And then finally, let's verify some solutions graphically. In red, we have the graph of y equals tangent x. In blue, we have the graph of y equals 1. The points of intersection represent the solutions. And notice how there would be an infinite number of points of intersection. The first angle we found was 45 degrees, represented by this point here. And if we add multiples of 180 degrees, we get the solutions in the positive direction. If we subtract multiples of 180 degrees, we get solutions in the negative direction. So this graph does verify our solution is correct. I hope you found this helpful.